Good morning, students. This is Max class. I hope all you are safe by God's grace. Today, we are going to do the continuation of the previous class, conjugate of a complex number. That we have to complete one example and few exercise problems that we will complete it in this class. In that, we have learned that if Z is equal to Z bar implies Z is real. If Z is equal to Z bar, Z is real. The same way, if Z bar is equal to minus Z, then we can say that Z is purely imaginary. Purely imaginary. Z equal to Z bar means Z is real, and Z bar equal to minus Z means Z is purely imaginary. So here in example 2.8, show that subdivision 1 they have asked we should prove that is real, and in subdivision 2 we have to prove that that is purely imaginary. So say I am going to take the first one as let Z. So Z equal to 2 plus I into root 3 the whole power 10 plus 2 minus I into root 3 the whole power 10. This we have to prove this is a real number. Say Z equal to Z bar. So shall we find out Z bar? If Z bar is equal to Z, we can say Z is real. If Z bar equal to minus Z, we can say that is purely imaginary. Say Z bar. So 2 plus I into root 3 the whole power 10 plus 2 minus I into root 3 the whole power 10 the whole bar. Now I am going to split it because we know Z1 plus Z2 the whole bar is equal to Z1 bar plus Z2 bar. Using this condition, we are going to split it. See, 2 plus I into root 3 the whole power 10 bar plus 2 minus I into root 3 the whole power 10 bar. Now we have that Z power n the whole bar can be written as Z bar the whole power n. Z bar the whole power n. Using that, when we do, we will be getting 2 plus I into root 3 the whole bar the whole power 10 plus 2 minus I into root 3 bar the whole power 10. Now we know that, isn't it? How imaginary unit symbol will change when we take the conjugate. So 2 minus I into root 3 the whole power 10 plus, and this will become 2 plus I into root 3 the whole power 10. So now if I write this as first term, that is 2 plus I into root 3 the whole power 10 plus 2 minus I into root 3 the whole power 10. Actually, what is that? That is what we have taken it as Z, which is equal to Z. So we have got it, Z bar is equal to Z, which implies Z is real. Hence the first subdivision we have completed. Second subdivision, we are supposed to prove that Z bar is equal to minus Z. Z bar equal to minus Z. But here this is given in fraction, isn't it? Both numerator and denominator we have complex numbers. So first we will simplify this. Okay. We know to simplify. See, I am writing 19 plus 9i by 5 minus 3i. When we have a complex number in the denominator, how to simplify it? We have to take the conjugate and multiply both numerator and denominator. So into 5 minus 3i, the conjugate is 5 plus 3i divided by 5 plus 3i. So this is x plus iy by, into x minus iy. So x square plus y square. So 5 square plus 3 square. Numerator we can multiply. 19 into 5, 95 plus 9i into 5, that is 45i. Then 19 into 3i, that is plus 57i and this is plus into plus, plus 9 into 3, 27 I square. This is 5 square, 25 plus 9, 3 square is 9, and this is 95, 45I plus 57I, that is plus 102I. This I square, we know the value of I square is minus 1, so we may get minus 27. So which is equal to, this is 25 plus 9, that is 34, and here 95 minus 27. See, when we subtract, you will get 68 plus 102I. Now we can divide it separately. See, 68 by 34 plus 102I by 34. So by looking itself, we can understand, isn't it? 134 and this is 2. Here 134 and here we may get 3. Or if you want, you can multiply and check it. 34 into 3, 4 3s are 12, 1, 3 into 3, 9, plus 1, 10. So we have got it. This is 2 plus 3I. Similarly, we should find it, simplify what is 8 plus I by 1 plus 2I. See, 8 plus I by 1 plus 2I. 8 plus I by 1 plus 2I. So, to simplify, what we should do? We have to take the conjugate, multiply both numerator and denominator. So, 1 minus 2I by 1 minus 2I. So, here, x plus iy into x minus iy. X equal to 1 and y is equal to 2. So, 1 square plus 2 square. Multiplied 8 plus I. This is minus 8 into 2, 16I minus 2I square. So, this is 1 plus 4, 8, I minus 16I is minus 15I, and I square, the value is minus 1. So, it will become plus 2. So, we may get that is 10 minus 15I divided by 1 plus 4 is 5. Now, 10 by 5 minus 15I by 5. See, when we divide, 1 5 is 5, 2 5s are 10, 1 5 is 5, 3 5s are 15. So, 2 minus 3I. So, there we got it 2 plus 3I, and here we have got it 2 minus 3I. So, now I am taking the question. Let Z is equal to 19 plus 9I by 5 minus 3I minus the whole power 15 minus 8 plus I by 1 plus 2I the whole power 15. So, actual value what we got it, this is 2 plus 3I the whole power 15 minus, and this we have got it 2 minus 3I the whole power 15. Now, shall we find out Z bar? So, if I find Z bar, this is 2 plus 3I power 15 minus 2 minus 3I power 15 the whole bar. Same like the previous step. Now, we can separate it. See, 2 plus 3I power 15 the whole bar minus 2 minus 3I power 15 the whole bar. Now, we can write it as 2 plus 3I bar the whole power 15 minus 2 minus 3I bar the whole power 15. Isn't it? For all this, if you want, you can write it. See here, Z1 minus Z2 the whole bar is equal to Z1 bar minus Z2 bar. The next thing is Z power n the whole bar can be written as Z bar the whole power n. Okay. Now, this conjugate we know. Plus will become minus, isn't it? 2 minus 3I the whole power 15 minus, and this is 2 plus 3I the whole power 15. So, in Z, first 2 plus 3I is there. So, shall we take the minus outside? When we take a minus outside, it will become positive. So, 2 plus 3I power 15, and it will become negative. That is 2 minus 3I power 15. So, this is minus, and this is what we have taken it as Z. So, now we have got it Z bar is equal to minus Z. Therefore, Z is purely imaginary. Is that clear? Shall we do a similar way? One more problem is there in the exercise. First we will do that. Okay. Exercise 2.4, seventh problem. Show that first subdivision we should prove that is purely imaginary, and second subdivision we have to prove that is real. What is the condition for purely imaginary? Z bar is equal to minus Z. So the given question we can take it as Z. Let Z is equal to 2 plus I into root 3 the whole power 10 minus 2 minus I into root 3 the whole power 10. So shall we find it out Z bar first? Z bar equal to 2 plus I into root 3 power 10 minus 2 minus I into root 3 power 10 the whole bar. So now we have to separate it. So 2 plus I into root 3 power 10 the whole bar minus 2 minus I into root 3 power 10 the whole bar. Isn't it? Next what we can do? We can take this power 10 to the whole power. That is 2 plus I into root 3 bar the whole power 10 minus 2 minus I into root 3 the whole bar power 10. Now we can find out the conjugate, isn't it? 2 plus I into root 3, that is 2 minus I root 3 power 10 minus 2 minus I into root 3 will become 2 plus I into root 3, isn't it? The conjugate. Now I'm going to take, the bar is removed, isn't it? Now I am going to take the minus outside. So it will become positive, that is 2 plus I into root 3 power 10. This is positive, isn't it? That since we have taken a minus outside, it will become negative. So now multiply and check it. This is minus, minus into minus, plus 2 minus I into root 3 power 10. This is minus. This is what the question we have taken it as Z. So we have got it. Z bar is equal to minus Z. Therefore, we can write that Z is purely imaginary. Is that clear? Now, subdivision 2. In subdivision 2, before we are going to take it as Z, we need to simplify this both terms because it is given in fraction. So 19 minus 7i by 9 plus I. So 19 minus 7i by 9 plus I into the 9 plus I, the conjugate of 9 plus I is 9 minus I. Now shall we multiply? See the denominator, that is 9 square plus the value of y is 1, isn't it? So 1 square. 19 into 9. That is 171 minus 63i. This is minus 19 minus into minus plus 7i square. Okay, see 9 square 81 plus 1 square is 1. Now 171 minus 63i minus 19i, that is 73, 9, that is minus 82i. I square, the value is minus 1. So plus 7 will become minus 7. So when we write 171 minus 7, that is 164 minus 82i divided by 82. Now shall we separate it? That is 164 by 82 minus 82i by 82. This both 182 is 82 and here 2 82s are 164. So we have got it 2 minus I. Now the next term we have to simplify. 20 minus 5i by 7 minus, see 20 minus 5i by 7 minus 6i. What is the conjugate of 7 minus 6i? That is 7 plus 6i. So with that we have to multiply both numerator and denominator. So this is x plus iy into x minus iy, that is x square plus y square, 7 square plus 6 square. Now shall we multiply 20 into 7? 140. This is minus 35i. 20 into 6i. That is 120i. This minus into plus. Minus 5 into 6. 30i square. So here the denominator 7 square 49 plus 6 square 36. 140 minus 35i plus 120i. Minus 35i plus 120i. We may get plus 85i. And this is I square, the value is minus 1. This minus, it will become plus 30. This is 170. 140 plus 30 is 170 plus 85i divided by 49 plus 36. 79 and 6, that is 85. Now we can divide 170 by 85 plus 85i by 85. This is 1, 2. So we have got it 2 plus I. There we got it 2 minus I, and here we have got it 2 plus I. So here I am taking, let Z is equal to 19 minus 7i by 9 plus I the whole power 12 plus 20 minus 5i by 7 minus 6i the whole power 12. So we have got this is 2 minus I the whole power 12 plus, and this value is 2 plus I the whole power 12. Now we have to prove that Z bar is equal to Z, isn't it? So shall we find out Z bar? That is 2 minus I the whole power 12 plus 2 plus I the whole power 12 the whole bar. Now we can separate it, isn't it? That is 2 minus I power 12 bar plus 2 plus I power 12 bar. So now as per the condition, Z power n the whole power bar can be written as Z bar the whole power n. So we may get 2 minus I bar the whole power 12 plus 2 plus I bar the whole power 12. So 2 minus I, the conjugate of 2 minus I is 2 plus I. The same way 2 plus I, the conjugate is 2 minus I, the whole power 12. In between plus is there, right? So even this I can write it as 2 minus I power 12 plus 2 plus I power 12. This is what Z. So we have got it now. Z bar is equal to Z. Therefore, Z is real. Is that clear? So condition for real number we know, that is Z bar equal to Z, and condition for imaginary, purely imaginary is Z bar equal to minus Z. So using that condition we have completed the two problems. Now problem number 4. The complex numbers u, v and w are related by 1 by u equal to 1 by v plus 1 by w. If v equal to 3 minus 4i and w is equal to 4 plus 3i, find u in the rectangular form. We have to find out the value of u. See, given, what is given? 1 by u is equal to 1 by v plus 1 by w. So from this we can find it out. See, v into w will be the LCM, isn't it? So here w plus v, is it not? This is 1 by u. U means what will be happening? Which implies that we have to take the reciprocal. W plus v. Is that clear? Now shall we substitute and simplify? V, the value of v, 3 minus 4i into 4 plus 3i divided by, that is 4 plus 3i plus 3 minus 4i. Shall we simplify this? This denominator is 4 plus 3, 7. 3i minus 4i, that is minus I. Numerator we have to multiply. 3 into 4, 12. This is minus 16i. 3 into 3, that's plus 9i. Minus into plus minus. 3 into 4, 12i square. So here, this is 7 minus I, 12 minus 16i plus 9i. That is minus 7i. This I square, we know the value of I square is minus 1. So it will become plus 12. That is 12 plus 12, 24 minus 7i by 7 minus I. But the question is, find u in the rectangular form. So the denominator complex number, we have to change it. How to change that? We have to take the conjugate and multiply both numerator and denominator. 7 minus I. What is the conjugate? That is 7 plus I by 7 plus I. Isn't it? The symbol of the I should be changed. So denominator x plus iy into x minus iy. So 7 square plus 1 square. Now we have to multiply the numerator. 24 into 7. 4 into 7, 28. To balance, this is 168. Minus 7 into 7, 49i. This is plus 24i. Minus into plus minus 7i square. So the denominator is 49 plus 1. This is 168 minus 49i plus 24i, that is minus 25i. I square, the value is minus 1, so it will become plus 7. Therefore 168 plus 7, 175 minus 25i divided by 50. Now separate the real and imaginary part. So we may get 175 by 50 minus 25i by 50. So 1 and here it is 2. This also it will be divisible by 25, isn't it? 2. Here 4 plus 3 is 7. So our answer may be 7 by 2 minus I by 2. Or if we want this 1 by 2, we can take it out into 7 minus I. Is that clear? Now problem number 5. Prove the following properties. Subdivision 1. Z is real if and only if Z is equal to Z bar. And the second one is real part of Z equal to Z plus Z bar by 2 and imaginary part of Z is equal to Z minus Z bar by 2i. This all we have learned in the properties. Here they have asked us to prove. Easy only. See the first one, we can take it, let Z is equal to X plus Iy, which implies we may get Z bar is that we know X minus Iy. Any one condition we have to take, isn't it? We can take Z is equal to Z bar implies. Okay. Z is equal to Z bar means what we may get it, X plus Iy is equal to. See, Z equal to Z bar, if we take, we have to prove Z is real, isn't it? Okay. Z equal to Z bar means X plus Iy is equal to X minus Iy, which implies, you see, bring all the terms to left hand side. Minus X plus Iy is equal to 0. See, X and minus X will get cancelled. This is Iy plus Iy is equal to 0 or 2Iy is equal to 0. So, which implies 2 cannot be equal to 0. I also cannot be equal to 0. So, the only possible is y equal to 0. Actually, y is the imaginary part. Y is imaginary part, isn't it? So, when we are getting Z equal to Z bar, the imaginary part will become 0. Therefore, automatically, we will be getting Z is real. The same way, when Z is real, the imaginary part will be equal to 0. So, we can write 2Iy equal to 0 or X plus Iy is equal to x minus iy. Put the double arrow. This same proof we have did for imaginary also. Okay. See the second subdivision. Z plus Z bar by 2. That's real part of Z. See, I am writing first. Real part of Z, what is that? X, isn't it? Here real part of Z is X. And the same way, imaginary part of Z is equal to, in X plus Iy means Y. We will check it whether we are getting that or not. Now, take the right hand side, Z plus Z bar by 2. That is Z, X plus Iy plus X minus Iy divided by 2. See, minus Iy plus Iy will get cancelled. 2x by 2. 2 and 2 will get cancelled. I have got it. X which is equal to real part of Z. Is that clear? Now, the same way, I am going to find Z minus Z bar by 2y. X plus Iy minus X minus Iy divided by 2i. So that is X plus Iy, give the minus inside, minus X plus Iy divided by 2i. Plus X and minus X will get cancelled. Iy plus Iy, 2Iy divided by 2i. 2i and 2i will get cancelled. So we have got only y. We know that y is equal to imaginary part of Z. Therefore, real part of Z is equal to Z plus Z bar divided by 2. And imaginary part of Z is equal to Z minus Z bar divided by 2i. Have you all understood this? Say one more problem we have in this exercise. That is sixth problem. I hope that after completing 2 or 3 more exercise, we can do it. Then it will be easy for you to understand. Okay, so after completing that, we will come to that problem number 6. So today there is no homework for you. In tomorrow's class, we are going to learn the new topic, that is modulus of a complex number. Okay, how to find out the modulus of a complex number. Okay, thank you students. See you in the next class. Bye-bye.